All right. So recording has started. So we didn't cover this earlier, so I want to jump back to this. And this actually falls right in line with the software upgrades that we were talking about, because some of the same concepts, the architecture and the way that Nimble is designed, go into how we scale a Nimble storage system. And we talked earlier about the drive layout and the size of the drives and the different controllers that equate to different models and whatnot, and all that comes into play in how Nimble scales. So there are three different ways that we scale: scaling up, scaling out, and scaling deep. Up meaning, right, we're adding performance, and that's how we get from one type of controller to the next type of controller in order to go faster. Scaling deep is simply adding capacity. And we already talked a little bit about adding shelves, but we'll go into that more. But then there's also scaling out, which is the ability to group multiple arrays together and aggregate their resources. And in this particular slide, it's showing the HF models, right? Starting at HF20s and scaling up to HF60s, adding shelves to those and then grouping them together. You can do the same thing for the all-flash systems, right? There's just less shelves that can be added, and there's a little bit different density, right? Because there's using the smaller drives in these Gen 5 systems. But you've got the AF20s up through AF80, adding additional drives or shelves on for scaling deep, and then grouping up to 4 systems together to aggregate resources. So let's just talk real quickly about scaling deep. An expansion shelf, this might look really familiar. The expansion shelves look, and it's the same chassis basically as what the controller shelves have. There's just no controllers in them, right? It's just a SAS backplane that's extended and connected using SAS cables to the controller shelf. But the drive layout, this is the adaptive flash hybrid expansion shelf. Drive layout's going to be exactly the same. First 3 slots are going to be held for cache. There's up to 6 drives that can be put in there. By default, they're configured with 3, but you'll want to configure bank B based upon what your flash to disk ratio, what you want that to be in the system once you add the shelf. These same 21 drive capacity drives laid out in slots 4 through 24. Same LEDs on the front indicating controller A and controller B connectivity and status, as well as the power button in the top right. But again, same drive layout that we talked about previously when we were talking about the controller shelves. Here's your options, though, for adding capacity to a hybrid array. Now, you don't have a bank A and a bank B, right? So if you're going to add capacity to the adaptive flash or hybrid systems, you have to add a shelf. And it starts basically, these ES3 is expansion shelf generation 3. It's the 3rd generation of shelf that Nimble has. And there's a 21, 42, 84, 126, 210, and 294 raw terabytes in each one of these capacity types. And you can mix and match these. If you've got 21 terabytes in your head shelf, you could add a 294 into the expansion shelf, as long as you don't exceed the max capacity for that controller, for that model. And you'll notice kind of how this works out, right? It's very straightforward. You got 21 drives, and it's 1, 2, 4, 6, 10, or 14 terabyte drives. Then by default, there's a certain amount of cache that goes in there. That cache is the bare minimum in order to keep a system running, right? It usually runs in the 4 to 5% flash to disk ratio, depending on where the cutoff is on the sizes. And sometimes it's a mix of different sizes like this one. And so if you want to be targeting best performance and you want to run deduplication, so you're targeting that 12% flash to disk ratio, you would then populate bank B in your expansion shelf based upon whatever that flash to disk ratio is that you're targeting. Here you can kind of see what the raw capacities are for each one of these, and they give you TIBs and terabytes, right? You can see that once you start getting up here, that's a pretty significant difference, right? Big difference between 294 terabytes and 267 terabytes. Here's your usable capacity for each one of the shelves. And this is going to be the same in a controller shelf too, by the way, because they're using the same type of RAID. And then here's your effective capacities based upon a 3-to-1 data reduction rate. So that's how those guys work. The all-flash shelves, again, they look just like the all-flash controller shelves. The expansion shelves are AFS Generation 3, FS3 shelves. You've still got a bank A and a bank B. When you first add an expansion shelf, you only have to have one bank populated to start with. And then you can add that, populate that second bank later. Again, same indicators and power button on the front. Oop. Here's your options, right, for configuration. It's pretty straightforward. You can do a max of 48 SSDs, 24 at a time, right? So one bank at a time is the way that works. And here's all the different sizes that you've got associated with that. So 1/4 of a terabyte, 1/2 a terabyte, full terabyte, 2, 4, and 8 terabyte drives. And again, those can be mixed and matched. Bank A and Bank B don't have to have the same size drives. And in the expansion, those can have different size drives in their Bank A and Bank B as well. So when you're connecting up the expansion shelves and you're scaling deep, you're basically connecting the SAS cable ports. This is the expansion shelf, right? See, there's no network ports or anything. Still got redundant power in the expansion shelves, but they've got these SAS ports, and they've got 4 per controller, which allows you to daisy chain if you need to add additional shelves. And those are simply going to be linked back to the SAS ports on the correlated controller. So this is for controller A, so this is going to be connected up into the controller shelf, into the controller A, and likewise for controller B. So because we can go up to 6 shelves on the hybrid and adaptive flash systems, generally this is the way the best practice is. You take port 1 or SAS port 1 on each controller and you take them to the first shelf. If you add another shelf, then you use port 2 to the second shelf. And then, oh, sorry about that. Then you're simply going to daisy chain off those, right? Because there's multiple SAS connections, you go now to the second set of SAS connections on shelf 1 to get your third shelf. Second set of SAS connections, daisy chain down to your 4th shelf, and so on and so forth until you have all 6. That's best practice. You could, theoretically, daisy chain all 6 of these off the same train of SAS cables. There's technically not a reason that wouldn't work. It does, you know, you're just increasing the chance of potentially having a bottleneck. It's 12 gig SAS connections on Gen 5, so it's probably not going to be a problem. But best practice would be to connect them up this way. The all-flash is a little bit different. In order to support the throughput of 24 or 48 SSDs, the 12 gig SAS is not enough in and of itself. So for every connection, you're actually utilizing both SAS connections. So 1 and 2 on controller A go down to the shelf, as well as with controller B, so that you've got a total of 24 gigs of SAS throughput on that. This is one of the reasons, and then you daisy chain down, right? And this would be your controller shelf, right? 1 expansion shelf, 2 up to 3 on the high-end systems. And so there's your, must have hit my scroll, sorry about that. That's how you're always gonna be daisy chaining on the all-flash systems. Yep, and I already kind of talked about that particular piece, right? One thing you want to make sure, right, when you're using both is that you're going from port 1 to port 1 and port 2 to port 2, not port 1 to port 2 when you go down here. Again, theoretically speaking, there's not a technical limitation there. You're just extending the SAS backplane. It will make the connections it needs to. The drive addresses will pass through on the SAS bus, but best practice to make sure everything runs smoothly is 1 to 1, 1 to 1, right? Once you connect up a shelf, or in this particular example in the screenshot, once you add additional drives, it's the same thing either way. You will log into the array, and in the hardware tab, it'll show up like this. If it was a shelf, it would show up with another little box. Oh, actually it does. So here's the controller, and we have the shelf selected right here. And then within the shelf in Bank A, which is on the bottom in this one, right? So it's not a Gen 5 system. All of the drives that are populated in Bank A, because it only has 24 drives, they all show up orange with the bang on them, right? And in order to bring those online, all you have to do is click the activate button. All those drives and their capacity will then be brought up into the pool. The RAID set will be configured, and you'll be off and you're going. So literally, it's racking it, connecting SAS cables, logging in, and hitting activate, and that's how you add capacity to a Nimble storage array. Very, very easy. to do that, and non-disruptive at that point. Like bringing that online isn't going to affect the front end performance or access of hosts that are already running on an active system. Any questions on adding shelves and capacity and activating it? Make sense? Cool. All right. So what does that look like logically speaking? So let's say that we've got a pool in our controller shelf here and it's 50% full. But we know that over the next few months, we're going to be rolling in some new applications with a bunch of more data, and we're going to run out of space. So we add our expansion shelf today. The way that that works, right, is that we actually fill the capacity of the drives on the expansion shelves up to match what's in the controller shelf before we start writing to both at the same time. And tomorrow we're going to talk about CASL, the Cache Accelerated Sequential Layout, the file system and I/O path utilized on Nimble Storage. And once we do, it'll make better sense, but there's no performance hit by doing this. You're not losing, you don't gain performance from the number of drives or the number of spindles in your Nimble storage array, unless you get up to really high-end systems, and we can talk more about that tomorrow. But basically, all your performance is going to come out of the controllers themselves. Therefore, you're not, by balancing this out, it means that the wear leveling on your drives is always going to be equal, and your capacity will always be evenly distributed, and there's very, very little post-process that needs to happen in order to keep your system balanced. Something to keep in mind if you have expansion shelves is when you power things on and off, you want to make sure you're doing things the right way. Because the capacity of the entire system is all inside the same storage pool, then you want to make sure that when you're powering it down, you turn off the controller first, and then you turn off your expansion shelves. Again, that might seem obvious, but best practice is not always people's common practice. In the same way, when you're turning it on, you want to make sure the expansion shelves are turned on before and powered up, and before you turn on the controller shelf. If the controller shelf comes on and it's looking for drives of capacity that aren't there, it might freak out a little bit. Now, that being said, Nimble is very, very, very careful with how it lays out its data and how it accesses it. Turning these on in the wrong order will not corrupt your data. There's checksums in place to make sure that that's never going to happen. That being said, it will gripe at you, and you will get errors and warnings about shelf being down, and volumes won't come online and things like that. So just keep in mind, what's the right order so that you don't get all those warnings and alerts. All right. Any questions about scaling deep? Cool. Let's talk about scaling up, model upgrades. I already talked about this a little bit. Basically, within any generation, so intra-generationally, you have the ability to swap out the controllers for faster controllers. So an AF20 can be upgraded to an AF40 or an AF60 or an AF80. And it's simply done by removing the standby controller, putting in the new controller that's faster, doing a failover between the controllers, and then swapping out the second controller. It's done non-disruptively. It can be done online completely. And as soon as you're running on that new controller, you've got the full performance capabilities of whatever that new controller is. So you could literally go from 20,000 IOPS to 400,000 IOPS in just a couple minutes. If you were going to, do that type of an upgrade. There are limitations around the partially populated systems. The AF20Q can only be upgraded to an AF40Q. And really what that comes down to is the smaller RAID sets in the Q models don't support any throughput higher than what an AF40 can do anyway. And that usually is, I've never had a problem with a customer needing to do that anyway, mostly because the AF20Q is usually deployed for very small deployments, so the performance requirements are generally low. Upgrades work the same way in the adaptive flash, both the C and the non-C options, right? A 20 can be upgraded to a 40 or a 60. And you simply do it by swapping the hardware controllers themselves. The HF20H, that half-populated system, again, there's some limitations around performance due to the RAID layout. It can't support performance higher than an HF40. So in order to upgrade, though, keep this in mind, you have to fully populate the HF20H first so that it becomes basically a regular HF20, then you can upgrade the controllers. You can add shelves at that point too, though, if you need additional capacity. So here's kind of how it works when you're upgrading the controllers. First, you always want to identify which controller you want to upgrade first, which one's the standby controller. Now, you could theoretically pull the active controller and the system would simply fail over, and it would work, and it's made to be resilient in those situations. In fact, I've run POCs with multiple customers, and that's part of what our testing is. We go in and we actually pull the active controller out in the middle of a workload to see what will happen. And the workload keeps running. So, but if you want to be nice to your Nimble storage array and you want it to be your friend forever, you want to go identify the standby controller. You can do that from the CLI by simply typing in control-list, and it will tell you which one's active and which one's standby, or you log into the UI under hardware and it'll tell you which one's active, which one's standby. And the standby controller is the one you want to upgrade first. This is how it works. So label your cabling first. Disconnect your cabling from your standby controller. Loosen the thumb screw, pull the release lever, which is this guy right here. It will eject that from the back plane, and then it'll allow you to pull the controller straight out of the chassis. Once that's done, then you take your new controller, your faster, super fast controller, you slide it back in, you lock it into place, you tighten up your thumb screw again, and then it's still running standby, right? Meanwhile, this whole time, your workload's been running on the controller that's still there, that's the active, and you're going to tell it to make active. Now the replaced controller, the upgraded controller, is now the active controller. You follow that same process on the new standby controller, and then you're up and running. And now, rather than an HF20, your model will automatically show up as an HF60. You don't have to re-register anything. You don't have to change a serial number with support, nothing like that. It's literally a component upgrade for the controller, and you just get more performance. Any questions on that controller upgrade process?
Just a quick question. So on the controller upgrade, when you replace the second controller, do you fail it back? Do you make sure that there are no issues, or does it just, how do you do that?
Well, when you put in the new controller, it will actually run the check against it. You don't need to fail it back. No, you could though. That's what I used to do because I'm a really paranoid systems engineer. Is after I did my controller upgrades, I actually failed it back again just to make sure.
Yeah,
but
that's what I would do. I would just want to make sure I understand the system that checks it, but that's the only way I'm a hands-on to make sure that everything's working correctly. But I'm probably too anal.
Yeah, I'm the same way, and I know I'm too anal. Yeah, but I mean, certainly there's the only downside to doing that is you're introducing another failover, and if it's a more performant time of your workload, you're introducing a little bit of latency during that process. So, but I mean, lots of our customers run software and hardware upgrades during the day, during online times because they're non-disruptive. I still scheduled mine after hours because I'm kind of paranoid that way, and I like to really have control over it. But I've never seen an issue with a controller upgrade where it's actually caused or hung or been a problem. So something else. So what I just described, though, are intra-generational upgrades, right? Meaning the controllers fit in the same chassis because the HF20, 40, and 60 all have the same chassis, right? The AF20, 40, 60, and 80s, they all have the same chassis. So the controllers will simply plug into each other as backplanes. But what's happened over time is Gen 1 and Gen 2 had the same chassis, but Gen 3 had a different chassis. And Gen 4 never came out. Gen 5 had a different chassis than that. And Gen 6, which was just released, the Electra systems, they've got a different chassis as well. In fact, it's a completely different controller design. We went to an AMD-based system rather than an Intel-based system. So the question is, well, what if I want to do upgrades intergenerationally? And the truth is it's supported. There is a process for doing that. We just released a SKU that you can buy an intergenerational upgrade, or the more financially wise and the higher value option is you can actually buy what is called timeless storage, which is a support Rather than a standard support, you get what's called timeless support, where you build in a controller upgrade every 3 years into your support contract. So you're simply paying for it with your support contract over time or upfront with your capital purchase. And then at the end of year 3, you get to be upgraded into whatever the newest generation is. You're guaranteed a 25 tick up in performance in the controllers in that process. And it's you get to keep your drives. You don't have to rebuy your capacity at that point in time. You can carry that capacity forward into the new generation. The current process does require a downtime outage. There is a non-downtime or an online version of that process that is being finished. The QA process is being engineered right now, and that should be fully released here in the next few months. Specifically, it'll be released in time for us to be able to support the newest generation, the Gen 6 systems. So timeless storage, if you're looking at new Nimble systems, for instance, if you were to buy a Nimble storage today, you can get Gen 5, but we just released Gen 6, but it's not going to ship for a few weeks, or the hybrid systems won't ship until the end of the year. So if you wanted a hybrid Gen 6 system sometime down the line, but you need to buy this summer, by getting the timeless storage, you're basically guaranteed to have Gen 6 or Gen 7 when it's time to do that refresh, and you can make sure that you're always moving into the new technology. It's a great way for total cost of ownership decreases significantly rather than doing forklift upgrades every few years. And it basically makes sure that the support of your platform continues on in perpetuity. So you can guarantee support for your platform for a decade or more, which is almost impossible to do anymore without like a program like this. So that's what the timeless option.
You mentioned something.
Yeah.
Oh, sorry.
Go ahead.
I'm curious. It used to be in the old days when you had spinning discs and fans. You'd push a SAN out for like 5 years, and then start worrying, right? Mm-hmm. You mentioned that with this option, you could keep the SSDs for as long as it's appropriate. But what is appropriate time-wise for an SSD that you have to start worrying about it?
Well, on a Nimble array, you don't ever, because Nimble automatically wear levels every SSD. I've never heard of an SSD wearing out. Now, that being said, another reason you don't have to manage that piece on a Nimble storage array also, because InfoSight is monitoring it. And if there's if an SSD starts to wear out, not like actually fails, but actually is reaching any kind of threshold that would cause a problem, you're automatically going to get a replacement SSD. It's part of your part of your support contract. So I'll give you an example. I actually did have a customer that's been running Gen 2 system in production for 7 years now, and they've run it really, really hard, and the cache SSDs actually were starting to get worn out. And InfoSight simply identified it, and we shipped them replacement drives. I mean, and then they just replaced them in tandem. You can do that non-disruptively. That's how that piece worked. But as far as all flash systems, you would have to run those things a long, long time. But again, it depends on your workload, right? I mean, as workloads continue to change over time, and we go into crazy warehousing workloads or AI workloads or HPC workloads where your IO is just millions and millions of IO all the time, even if it's small block. You have there's always the potential that you could run out an SSD or something. But I'm
showing my age then, right? Because it didn't used to be your SAN was hooked up to the cloud that was always monitoring it, right? You had to monitor with SNMP and didn't know it was going to break until it broke, right? So it's just a newer system.
Yeah, and that you've hit the nail on the head there, and that's actually one of the primary benefits to running Nimble, period. I mean, lots of different vendors can offer you fast storage, right? That you can connect in different ways, and easy isn't even necessarily a huge differentiator anymore either. I know there's other platforms out there that are easy to manage and easy to deploy, just like Nimble is. Though I have to say Nimble is definitely one of the easiest ones I've ever touched. But the InfoSight AI backend is going to be one of your, it's basically IT augmentation. It's doing a lot of the stuff that you used to have to do manually, and that a lot of other platforms still make you do manually. It's just doing that stuff for you.
Yeah. Cool. Thanks.
So let's see, I won't dig into that. I guess I will point out this piece. When we're talking about intergenerational, or when you're using the timeless program to do intergenerational upgrades, just keep in mind this is the way that it works, right? If you are using timeless upfront, yeah, there's going to be more cost, right? Because your support contract is going to be more expensive in order to support the hardware upgrades that are coming down the line, right? Nothing's free. We're just building that controller upgrade into the overall cost of your support. So this is, if you look and see what does the cost look like over time, yeah, you're going to pay a little more upfront, but you're going to pay twice as much at year 3 if you did a refresh compared to 1.5, and then 3 times as much, right, once you get out to your second refresh compared to 1.75. So you're looking, it really does end up being a savings of over 100% when you go with a timeless compared to doing, with a 3 to 5 year refresh over time if you stayed on the same platform, which is always our preference, right? There's less risk when we can stay on that same platform as well. And what does that look like is every 3 years you're offered that upgrade. So you could theoretically by year 9 be moving into whatever the newest generation is at that point in time. There's even the capability, let's say that a new type of media comes out over the next 10 years and you want to take advantage of that. You don't want SAS SSDs anymore. Then we'll actually buy back the capacity from you. You won't lose the money you invested in that. And you can apply that toward buying new capacity in whatever the new media is. By your second upgrade, you can do that at 6 years. Also, you have the ability, for instance, if you buy this year and or you buy an adaptive flash system this summer, and we know that the new adaptive flash systems are going to come out, sometime at the end of the year. But so you're like, oh, well, I just missed out. Well, not on timeless. You can actually bring that upgrade into a 1-year mark from the 3-year mark. So even by next summer, you could then upgrade to the new platform and be running on Gen 6 if you wanted to. So a lot of benefits, right? Yes, there's a little more money up front for the timeless, but the overall TCO is much higher. And it does allow you to keep moving forward in technology and always have the newest platforms and newest capabilities and newest efficiencies. All right. Scaling out is the last piece I'm going to talk about. Let's see, what do we got? Okay. Yeah, I'm just kind of gauging. We were going to talk about InfoSight again today. We'll touch on it a little bit, and then I'll probably pick up some more on InfoSight tomorrow as well. But let's talk about scale out. The concept is this, that you can take multiple Nimble storage arrays, you can group them together so that they are basically being offered up as a single storage system to your hosts, right? Here's my VDI, my server environment. When they look down and they see multiple systems grouped, they're seeing one storage system with multiple storage pools. So, and you can actually span pools across multiple arrays as well. That's usually, I can only think of one customer that's ever done that. Generally speaking, what happens is you have a single pool per array, but they're all grouped together. And then you simply have the ability to choose what pool you're going to put your volumes in. And the hosts, they don't care. It's one storage system to them. So the nice part about this, though, right, is that because you can span pools, because you can put arrays in and out of a group, when you want to make a change, you can pull an array out and you can bring in a new array, and you can simply move workloads into, independent or unbeknownst to the hosts between the different pools, because it's one storage system to them, right? It doesn't change the fiber channel connections. It doesn't change the iSCSI connections when you're moving it from one array to another, because it's on the same zone. It's the same portal address on your iSCSI as you access the particular group. So you can actually move volumes between the pools underneath, right? Which it supports great things like refreshes and migrations. If you move to a new storage platform, you can group them together, move all your volumes on the underside, right? You don't have to do migrations at the application level anymore. You can move them into the new pool and then eject your old system out. Again, the management looks like this. When you log into your management UI, you're looking at the entire group. You go to hardware and you can see both systems in the group. There's lots of different ways that you would use that. Like I said, you can span pools across multiple arrays. Usually, though, it's one pool per array. The arrays can all be different too. It doesn't have to be all four or all, all the systems in it don't have to be all HF20s. And they don't even have to all be all flash or all adaptive flash. You could have array 1 be, a high-end AF80, and then array 2 be a low-end HF20. And you can have those in the same group. And as long as they have their own storage pool, each pool will have its own performance aspects and capabilities, but it's one storage system from your host standpoint. So it simplifies management, it simplifies data movement significantly, and can really be beneficial also in migrations and whatnot. Let's see if I've got, so what does this look like? One of the key things that you need to keep in mind, though, in order to support scale out groups on Nimble Storage, it does require some additional intelligence to be injected into the hosts so that they know what path to use when they're sending a block down to the underlying storage. And that's done through what's called the Nimble Connection Manager, or the NCM. And really, this is an overlay driver, a DSP, that lies over the iSCSI or the fiber channel and manages multipathing and basically injects that intelligence. It communicates with the array, so it can keep track of what paths are the right ones in order to access what volumes. And then it injects that intelligence into the multipathing of the iSCSI and fiber channel at the host level. So if you're going to run scale out groups, you do have to install NCM on every host that's going to access that group in order to be in a supported configuration. The truth is, I as a customer didn't know that the first time I grouped. And I didn't use NCM, and I was managing those paths manually. Then I talked to my SA. He explained to me that I needed to install NCM. I installed it, and all of a sudden, all my paths came up the right way they were supposed to in VMware, and I wasn't having to trim them manually anymore. So anyway, something to keep in mind. NCM also, besides the pathing piece for groups, it also optimizes iSCSI and fiber channel connections for better performance and lower latency. It also injects some more intelligence so that we can pull some additional telemetry information into InfoSight as far as networking and connectivity standpoint. You've already gone through this point of initializing your array, and you're going to, the next lab is going to be creating a volume on a host, on a Windows host. And you're going to walk through this process, but basically you go and you find the portal address for each of your data subnets, and you point your system at that, and then it will find the rest of the addresses. And once NCM is installed, then it will set up the correct pathing for the different volumes. Any questions about scale out and grouping? Make sense? I'd like to just do one little thing here just to make sure that everybody gets it. Where is my whiteboard? Here it is. See if it'll let me do this. So here's kind of the concept. Ooh. We've got array 1, and we're going to say this is an all-flash array, right? Got array 2, and this is a hybrid array, and they're in a group of 2, right? And as far as we're concerned, here's my hosts. They're accessing the portal address for the group, and each one of these systems has their own pool. And then within that pool, right, there's going to be volumes. The beauty of being able to do this is, let's say that I'm running a SQL system inside this volume. Right? So really SQL's running up here in a VM or on this physical host, but the data sets and the IO is running out of this volume. And let's say that I've been running it in test dev. That's why it's an HF, right? It's my test dev system. But I want to see how that's going to run once I get it into production. I can, on the back end here, I can migrate this volume over to the other pool, and it will be non-disruptive. The hosts don't know and they don't care because it's the same storage system. It's the same iSCSI paths. It's the same fiber channel paths as what we had before. So that's called a bin migration. We can move a volume back and forth and basically put it where you want it to be, and do it in an automated fashion. This is something that could be scripted very, very easily utilizing the API if you wanted to automate a process like that. Let's say that at the end of each month, you want all the reports to run faster, but you don't want to be using up all your all-flash capacity for those systems all month long. You could literally automate a move and then a move back if you wanted to. I actually have had some customers do that. So there's one use case, right? Is basically creating a tiered system. This is the other one. You've got a CSXXX. So this is an old Gen 2 system. It's going end of life later this year. It's got its own pool, right? And it's got its own volumes. And you're going to be buying a new Nimble array. You're buying a great HF60. And you're going to be, you're going to get some increased performance. You're moving to Gen 5. And so when you bring that in, if you group those together, right, because the group, right, they've been accessing the CS, but once you group these together, now they can see both pools, right? So your host can see everything. You simply move all your volumes over to the new pool. Then at that point in time, you can make the new one the new group leader, and you can eject this out because it's not supported anymore, and you're back down to a group of just one. And now you've done basically a non-disruptive upgrade of your entire data set with all your hosts still online. Now, granted, I had to install the Nimble Connection Manager up here at the host level in order to make this to work. There's always going to be caveats, but that's the secondary use case that we see most commonly, is doing migrations or I guess adding an additional capacity or expanding capacity, utilizing groups and then moving volumes over into new pools. All right. Other ways that you can scale on a Nimble storage array is by adding cache. Sometimes you need more cache in order to support the performance you need on an adaptive flash system. Cache can be added if you have any open cache slots, so the 6 slots per chassis that you have, whether it's in an expansion shelf or in a controller shelf, all cache goes into the same pool on a Nimble storage array. And so it's not really broken up or assigned to a particular workload when we're talking about SSD cache on the hybrid systems. And so if there's open slots, you can simply get 3 more drives. They come in banks of, you fill out a bank at a time. Each bank has 3 drives. You can buy 3 more drives of whatever capacity you want, and you can put it in, to target whatever performance level you need. If all of your cache slots are already populated, but you need additional capacity in your cache, you can actually pull out old smaller drives and put in larger SSDs. And we'd want to target that, make sure we size that properly. But the concept here is, right, in this case, if you went into the executive dashboard in InfoSight, it would show you this. And if you're overrunning your cache, it would tell you actually how much you're saturating it and by how much, and then it would give a recommendation of how much cache you needed. In this particular case, now I could pull out smaller cache drives and put in newer ones. Best practice shows that anytime you pull out a cache drive, what are you pulling out? You're pulling out the cache that's on that drive too, right? So there's actually a performance impact, right, when you're pulling out drives or when you're swapping them out. So best practice is that it's a 3-day process in order to upgrade a bank of cache. You pull out one drive and you put in the larger drive. The drives do not have to match in size, so it doesn't matter. Every drive individually adds itself to your cache pool. And at that point in time, then your cache will start to warm up. That new drive will start to be populated with cache data. And the best practice is you wait 24 hours for it to get fully warmed up. And it's a larger drive than the previous one you had. So now actually you have more cache than what you had by an increment. And then you follow that same process on the next 2 drives, so that over 3 drives, you've replaced all the drives and you're not pulling out too much cache at once. Right, and trying to warm up too much cache at once. So by spreading that out over those 3 days, you're basically minimizing the impact to your performance over time, but still upgrading your cache. Yeah, so I talked ahead of the slides here, but basically if I remove the drive, it shrinks my cache pool. If I add another drive, then it expands the cache pool. It's all completely dynamic. You don't have to configure it. And unlike the capacity drives, you don't have to activate cache drives. As soon as they're there, they're automatically recognized and the cache is utilized. All right, any other questions about scale? Scaling deep, scaling up, scaling out? Nope.